So guys, if you are new to my channel, then please subscribe to this channel and click the bell icon to get the notification for upcoming videos. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about different levels in software testing. So there are 4 levels in software testing. We have unit level testing, integration level testing, system level and acceptance level. So these are the 4 levels in software testing. Now if we talk about unit level, so let me recap. We already spoken about software development lifecycle. So there are different phases in software development lifecycle. We have requirement analysis, feasibility study, we have design, coding, testing, release and maintenance. So these are the different phases in any software development lifecycle. Now what happens is, when we get the requirement from the customer, when we do the analysis of the requirement, feasibility study of the requirement, then we go for the designing part. So once design is done, then we go for the actual implementation of the code, or you can say coding phase. Now what happens in the coding phase? So as a whole, we cannot develop the whole system, correct? We cannot get all the requirements from the customer and develop as a whole. So we need to divide the task into different modules. So let's say in our take an example, in our case, we have divided them into different modules like module A, module B, module C and module D. So we have 4 modules, guys. Now what developer will do as part of unit testing? So what they will do is they will develop the module A, and they will verify each line of the code whether it is functioning correctly or not. So they will done the development for the module A and they will test it themselves. So that is unit level testing, guys. So basically they will check that particular module is working perfectly fine or not as per the requirement given by the customer. So that is module A, and similarly they do it for module B, C and D as well. So this is how it is happening in unit level testing. Now the second level is integration level testing. So what happens in integration level? So once all the modules are integrated, and unit level testing is done usually, like most of the cases, by developer guys, and sometimes it is done by white box tester as well. So the person who has sound knowledge in terms of technical things, then they can do the unit level testing. Now we talk about integration. So once modules are integrated, once all the modules are integrated, now we have to check the functionality, like the data flow from module A to module B, module B to module C, C to D or D to A. Basically we need to check the data flow from one module to another module. So that is the purpose of integration level testing. So who will do this integration level testing? So sometimes a developer used to do the integration level testing, like in most of the cases, and sometimes we used to do with the help of tester, used to do with the help of developer, that integration level testing. Now moving on, the system level testing. So what happens in system level testing? So when we test integrated system, or as a whole, when we test a system, the complete system, that is called the system level testing. And in this particular testing, testers are involved, and here we do manual as well as automation testing. And in system testing we do check all kind of functionality, or all kind of non-functionality as well. So basically we do functional testing as well as non-functional testing. So most of the testing comes in system testing, guys. So that is all about system testing. Now moving on to the acceptance level. So end user will do the acceptance level testing, whether the software is working correctly as per their requirement or not. So to check that, they will do the UAT level. So once testing is certified from our end, we send it to the UAT, where they will check, and customer and end user will test at their end or at developer's end, like whether it is working perfectly fine or not. So there are a couple of types of user acceptance level, guys. We have alpha level and beta level testing. So we'll talk about them in detail, like that will be a separate topic. And if we talk about unit level testing also, we have some unit testing techniques as well. So I'll talk about them in a separate video, each level of the testing. So this is all for today, guys. I wanted to talk about what are the different levels of testing and some brief introduction about the test levels. So this is all for today, guys. Thank you for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by unit testing and what are the different techniques used by the developer or development team to do the unit testing. And at last we'll talk about what are the advantages and disadvantages of unit testing. So let's get started. So the first thing is, what is unit testing? So guys, we have already spoken about the software development lifecycle. So there are certain phases in software development lifecycle, like we have requirement analysis, feasibility study, design, coding, testing, release, and maintenance. So these are the different phases in software development lifecycle. So once requirement analysis is done, feasibility study is done, then we go for the design. And once design of the software is done, then we go for the actual implementation of the software. That is nothing but the coding. Now take an example. In our case, we got some requirement from the customer. Like we got one project for the website development. Now in any website, if you see, there are certain pages which are common. So let's say in our case we have registration page. So these are the common pages we can see in any website. So we have registration page, we have login page, and then home page. So what happens is, whenever we get any requirement from the customer or project, so we cannot develop that project together, like as a whole we cannot develop at once. So what developer does here is, they will divide the task into different modules. So they will divide development task into different modules. So in our case here, you can see module, this is module A, this is module B, and here we have C. Similarly, we have some other pages, and just for example, guys, here we have registration page as module A, and we have certain fields in registration page, like first name, last name, we have the user name to for the login purpose, and then we have email ID, phone number, etc. are there in registration page to register for this website. So once registration is done, we will get the link in the email, and once we verify the link, we go for the login. To enter username, password, and click on submit button, will land in on the home page. So this is the flow of our website, or normally in any website. So what happens is, we get some requirement or project from the customer. So we'll divide them into different modules: module A, module B, module C, and module D. So these are different modules we are developing. So what developer will do? So they will go and they will do the development for registration page first. So they will pick up the module A, and they will start development of the registration page. So they will do the coding, everything they will do. Once the development of registration page is done, they will do the unit testing. They will do some kind of testing at their end. So that is nothing but the unit testing. So they will verify internal structure of the program, whether they have written, whatever code they have written is correct or not, and the UI and everything, whether as per the requirement there or not. So they do some kind of internal structure testing, and they'll do some functionality as well, like after doing the registration, whether we are getting the receiving the email or not for the verification purpose. So they will not do the detail level testing in terms of functionality, but they'll do some internal structure testing. So that is unit testing. So once unit testing for module A is done, they will go for module B development, and they will do the unit testing over here. And similarly, they will go for module C. Once all modules are done, they will integrate for further integration, and they will create the integrated system, and that will go for integration testing. So this is about unit testing, guys. So let's see some definition of unit testing. So unit testing is a software development process in which individual units of source code modules are tested to determine whether they are fit for use or not. Fit for use means whether we can go ahead with the further process or not. like for integration of all the modules and then integration testing. So that is the main purpose of unit testing, like individual units of source code should be tested properly, or modules should be tested properly as part of this unit testing. Testing is conducted by developer or white box tester. So this is usually done by the developer or white box tester in some companies if they had a white box tester, and the person who has very good knowledge in terms of technical things, so that they can do the unit testing. So to conduct this testing, programming knowledge is required. So this is what I was talking about. So this technique allows developer to analyze code. So just concentrate on this one, guys. So this technique allows developer to analyze code, catch bugs earlier and fix them faster. So the main purpose of unit testing is to get the defect as early as possible. Like they will analyze the code, they will do the code review, and if everything goes well, they will do some kind of functionality testing as well. So their main motto is to get some defect early as possible so that they can fix them as soon as possible before they go for the integration and integration testing. Now, what do you mean by this unit test life cycle? So there are certain process, guys. So certain stages in this unit test life cycle which developer used to follow. Now let's say they have developed module A already, they have developed, and this is into remote repository. Already they check in the code and put into remote repository. So whenever we work in any company, guys, so we used to follow certain repository, like let's say in this case we have GitHub. So GitHub, so to check in the code so that other team members can share their code as well, they can check out the code and they will make some changes as well. So to work in a team environment, we have to use some repository. So in our case, the developer, we have developed module A. One developer has already developed, let's say X developer has already developed module A and check in the code into the repository. Now what that developer will do, first first process is check out the code. Check out code. So check out the code from repository, and the second thing is execute unit test cases. So developer will write some test cases, guys, with themselves for unit testing. They'll create some scenarios, not in a formal way, but they used to have some kind of scenarios to execute the unit test cases in terms of internal structure of the program, how they will review it, and some functionality as well, whether that is working correctly, perfectly fine or not. So the first one is check out the code from the repository. Second is execute unit test, and the third one is, let's say as part of unit testing they get some defects or defects or error in the program. So what they will do, they will fix the defects and error. Now the next point is code review. So after executing the unit test, we get some defects, guys, defects or error, and they will fix those defects. They will fix the defects. The developer will fix the defects, and they will ask the other developer to review the code. So in this case, we have developer X, so they will ask other developer Y to review the code, and then what is the last? Check out the code. Check in the code. Check in the code. Check in the code into repository. So this is the kind of life cycle of a developer, guys. So this is what they do whenever they go for the unit test. This is unit test life cycle. We have check out the code and then execute the unit test. We'll fix the defects or error if we get any on the code, and then code review by the peer review or code review by the team, other members in the team, and then check in the code. So this is how the life cycle of unit tests. Now the next thing is, what are the different unit testing techniques we have? So we have structural testing techniques. So this is, again, there are 4 types of structural testing techniques we'll discuss in coming slides. We have functional testing, and we'll do some kind of functional testing as well, guys, as part of unit testing, as I have discussed earlier. And error-based testing techniques. So we have couple of error-based testing, like error seeding, which we'll discuss later, and the next one is mutation testing. So we'll discuss in coming slides about error-based testing techniques as well. So let's talk about structural testing techniques first. So structure-based testing techniques use the internal structure of software to derive the test cases. So to derive the unit test cases, so we'll do this structural testing technique. So yeah, it is white box testing technique. It required programming skills. So since we are talking about the unit test cases, so it requires programming skills. So these are the 4 types, guys. We have statement testing, condition testing, statement, test, condition, branch, and path. So these are all related with internal structure of the coding, guys, internal structure of the program. So what do you mean by statement testing? So testing each line in a program at least one time. So let's say we have developed module A. Now, so we have to go through each line of the code and execute each line of the code at least once. Like we have to execute our program, verify all the we'll do some kind of code review as well, so verify that everything is perfectly fine uh, as part of this, for programming of or development of module A. Condition testing, so verify the conditional statements are working correctly or not. So what we have if, and we have if else, we have nested if, we have switch statement. So we'll make sure every what all the conditional statements we have all should work properly, all are executed properly as part of this condition testing. Branch testing, so verify all the branch statements are working correctly or not as part of branch testing. So we have break, continue, and return statements in for loop. So all those statements or branch statements should work correctly as part of this branch testing. So that is what we do as part of this branch testing. And another one is we have path testing. So testing the flow of the execution of the program. Basically we test the flow of the execution of the program in this path testing. So developer will use some workflow for their development, guys. So for, let's say, for module A, they have written some workflow. So all should be in a proper manner, like the execution of the flow of the program is proper as part of this path testing. So these are the 4 structural testing techniques: statement, condition, branch, and path. Now if we talk about functional testing, so let's say they have developed registration page, correct? So which we have seen earlier, registration page. Now what they will do, they will do some kind of functionality check on this registration page. So some kind of functional testing we do as part of unit testing, guys. So developer use some functionality check, like they will themselves they will do from their end some functionality check, like they will enter username, they will enter first name, last name, and after entering all the fields, they will go for the register, and they will verify whether we are getting the email or not. So some kind of functionality they will check. They will not go into detail like a tester, but they will do some kind of functionality check as part of functional testing. Functions are tested by feeding them input and examine the output. So this is the functional testing. Functional testing ensures that the requirements are properly satisfied by the application. And functional testing is a quality assurance process and a type of black box testing. So where what do you mean by black box testing? We don't care about the internal structure of the program. We just see the functionality is working properly, working perfectly fine or not. So however, we'll discuss more about functional testing when we talk about system testing, guys. So but the developer also do some kind of functional testing when they go for unit testing. So that is the purpose I put it here, like functional testing. Now error based testing techniques. So there are a couple of example I have given over here, like couple of types. So we have error seeding and mutation testing. So what happens in error seeding? So what they will do, developer, they feed some error, they will seed some error, seed or feed errors in the program, and they will verify like how what are the actual errors in the program by putting the what you can say artificial error in the program. How they do that, we'll see in the next slide with the help of an example. Mutation testing. So what do you mean by mutation testing? So what they will do, let's say we have written some program over here, let's say we have some statements over here. Now they will change it to, they will change something in the program to make sure whatever they have written is correct. So for this one, these changes, they should get some error or message, correct? So they will make sure that whatever they have written inside the program is correctly after making the changes. So after making the changes, we should get the exact message or exact flow. So that is the main purpose of this mutation testing. So I'll talk about an example in the coming slides. Let's talk about error seeding first. So I got this question in the internet, guys. So this was asked in the Gate exam. So a software tested using, and this is error seeding example, error seeding. So a software was tested using the error seeding strategy where which 20 errors were seeded in the code. So developer put 20 errors in the code, seeded in the code. When the code was tested using the complete test suite, 16 of the seeded error were detected. So out of 20, we got only 16 of the seeded errors were detected. So the main purpose of error seeding is, since we won't get the exact number of errors, so uh, that's the problem. So that to avoid that, we go for the error seeding technique to derive the actual number of errors in the program. So the same test suite also detected 200 non-seeded errors. So non-seeded errors are 200. What is the estimated number of undetected errors in the code after this testing? So this is the question. Now here we have four options. So how to resolve this? Correct. So we have a formula, guys. So let me write the formula. So found or detected seeded error in the program. Detected seeded error. Let's say, let's denote by this with n, and total seeded error. So what I have written here, detected seeded error divided by total seeded error. Now equal to, we have detected non-seeded error, non-seeded error divided by total non-seeded error. So this is the formula, guys. So detected seeded error n, this is, let's say, n, and this is r, small r, and this is capital R. You can see detected seeded error. We have detected seeded error, we have 16, correct? And divided by total seeded error, we have 20. We have error seeded in the program. Detected non-seeded error, we have 200. So we want this total non-seeded error first of all to derive the estimated number of undetected errors. So we can put the values in the formula. So we have 16, which is detected seeded error, which is 16, and divided by 20, which is total seeded error, which is this one. Now detected non-seeded error 200 divided by this r. So r will be 200 into 20 divided by 16, 4 4 is 16, 4 5 is 20, and 4 5 is 20. So total 250. So 250 is the this one, total non-seeded error in the program. Now we have to derive it, right? So total is 250 non-seeded error minus what is 200. 200 is non-seeded error. This is non-seeded error, right? Total non-seeded error is 250 we got, and we got the we already got, right, non-seeded error, which is 200. So what is undetected? Here you can see undetected errors. So undetected errors will be 50. Hope you got this answer. If you don't get this, then if you are not able to understand, then please let me know in the comment box, so I'll explain again. So we got the answer 50, which is undetected error in the program. So this is how you can derive the undetected errors with the help of error seeding. So before that, let me give an example of mutation testing as also, guys. So I don't have that slide as of now. So, and later on we'll discuss about the advantages of unit testing. So mutation testing, what happens is whenever we make any changes in the code, and then we'll see what is the behavior after making the changes. So let's say if we have we have some statement A is greater than B, so C is 20, else C is equal to 30. So this is my actual program. If A is greater than B, C is equal to 20, else C is equal to 30. Now I'll change it, we'll mutate some program. So we'll change this program to if A is less than B, C is equal to 20, and else C is equal to 30. So this is what we made the changes in the program. So here you can see we have less than symbol over here. So there are three types of three types of mutation testing as well, guys. So we have value, decision, and statements. So this is decision related, like we have changed the symbol over here, the operator, arithmetic operator I have changed over here. Now this is mutant program. And we'll verify as per this program whether we are getting the expected outcome or not. So definitely we'll get some error for this program, so that will make sure that this program is perfectly fine. The program which we have written is perfectly fine. So this is the main intention of mutation testing. So we'll make sure that whatever code we have written inside this if else, all are working fine. So this is just an example I have given with the help of if else block. So in the main program, it will be like more coding. So now let's talk about what are the advantages of unit testing. So unit testing significantly improves code quality. So we do a lot of internal structure techniques we apply, and then we'll do code review as well. So unit testing significantly improves code quality. Unit testing helps identify all kinds of issues with the software at very early stage. So this is the biggest advantage of unit testing. If there are any problems, they are detected early on, and making changes to the system thus become much easier. Reduce cost. So as soon as we get the defect, we'll fix them as early as possible, so cost of the project will be reduced. Now what are the disadvantages of unit testing? So it's difficult to write quality unit test cases, and the whole process can be time consuming. So this is very time consuming process, guys, if you do a lot of unit testing. So sometimes it's very difficult to do the unit testing as well. Not all errors can be detected. So we cannot find all the errors in the program, since every module is tested separately and later different integration bugs may appear. So right now we have tested a separate module A, B, C, D, A, B, C, and D. But once they are integrated, correct, so we may get some more defects later on. more defects. And also they have done the integration, sorry, unit testing only. So when we do the integration, when we go for integration, we may get some more defects as well. So this is, I think we are done. So this is all for today, guys. So thank you for watching. If you are new to my channel, then please subscribe it and click the bell icon to get the upcoming interesting videos. Thank you so much. Have a nice day. Bye bye. So guys, if you are new to my channel, then please subscribe it and click the bell icon to get the notification for upcoming videos. Thank you. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by integration testing and what are the different approaches of doing integration testing. And later we'll talk about what are the advantages and disadvantages of integration testing. And if you talk about like who is performing this integration testing, so it depends on companies' practices and preferences. So in most of the cases, it is done by testers itself, but in some companies, it is done by developer as well. Now let's move to the next slide and talk about what do you mean by integration testing. What is integration testing? So what do you mean by integration first? So integration is nothing but combination. So when we test two or more modules together, then that is called integration testing. So let's say we have module A and module B. So when we test these two modules together, that is nothing but integration, and we'll see the interfaces, the connection between two modules, like how the data is flow from module A to B and from module B to A. So that is what the purpose of integration testing. Now if you remember guys, in the previous video we talked about unit testing, and there I have taken an example of website development. So let's say we are developing a website and we have home page, login page and home page in our website home page. So this is module A and this is module B. Now when we log in into this application, we have username and password and then submit button. So once we enter username, password and then click on submit button, then we'll navigate to home page. And this depends on this home page until unless we won't land on the home page when we until unless if we don't provide the username and password and click on submit button. So these two modules are dependent on each other. So when we test these two modules together, that is nothing but the integration testing. Now let's talk about some of the let's look at some of the definitions of integration testing. So testing is conducted by integrating two or more component is called integration testing. With the same system or two different systems are integrated. So it doesn't mean that within the system, if we integrate multiple modules, is integration testing. So in integration, we may integrate multiple systems as well. It is a phase in software testing in which individual software modules are combined and tested as a group. So this is the meaning of integration testing. During the integration, we verify the data communication between the component. This is what I have spoken about, guys. So how the data is flow from module A to B and B to A. We calculate the performance, time taken to complete the transaction. So this is another parameter we verify when we do integration testing as well. We calculate the performance as well, like how the data is flow, how the interface between module A to module B, time taken, how much time it is taking the data transfer from module A to B. That is also matters in integration testing. We verify the function of the application, functionality of the application. So this is an example, guys. So here we have module A and module B, and this is the common between these two modules, where these two modules are integrated, right? I mean, this is the common place where we perform the integration testing, the interface between module A and module B. So in case of login page and home page, so when we provide username, password and click on submit button, then the next thing will land on home page. And similarly for home page, until unless if we don't provide username and password and click on submit, we won't land on home page. So that is the integration between home page and login page and home page. Now let's talk about what are the different approaches we have to perform integration testing. So we have big bang integration approach, and we have incremental approach, where again we can divide three types, like top down integration, bottom up integration, and mixed or sandwich integration. So what do you mean by big bang integration? So big bang integration, when we combine all the modules together and test, that is nothing but the big bang approach, when we combine all the modules together and perform the testing. So this is big bang approach. What do you mean by incremental approach? So when we combine one module to another module and perform testing over here, and then combine to another module and perform testing here, combine another module and combine testing. So this is incrementally, we are adding one module at a time. So that is incremental approach. Again, incremental approach is three types, right? We have top down integration, bottom up integration, and mixed or sandwich. So top down, bottom up, and then mixed integration or sandwich integration. We'll discuss about them in detail in coming slides. So what is big bang integration approach? So testing is conducted on multiple components together. All the units are tested together as one single combined unit. So this is what I have spoken about in the last slide. This form of integration testing works well for smaller systems. So there are some limitations in big bang approach, guys. We'll discuss in next slide. Yeah, so this is the big bang approach. We have one system, and here all the modules are combined, all the units are combined, and when we test, so this is nothing but the big bang approach. Now what are the limitations faced in big bang integration approach? So in this approach, detailed testing is not possible. So detailed testing is not possible because we have combined all the modules together, and we don't know how the data is flow from one module to another. So it is time consuming process, and it's very difficult to check like how the data is flow from A to B, B to C, C to D, and then A to D or D to C, like that. So it's very complicated to test when we follow this big bang approach, particularly in big for big projects. Not possible. If any defect is found, it will take time or effort to analyze the defect. So it is also difficult to find the root cause of the defect in this method, because we don't know like how the data is flow. So it's very difficult to find the root cause of the defect. Critical modules are not prioritized, which could increase the overall risk. So this is another limitation. Critical modules are not prioritized, which could increase the overall risk in the project. So these are different limitations when we follow big bang approach, and it's time consuming as well. Now let's talk about incremental approach. So in incremental integration testing, the developers integrate the modules one by one, which I have discussed. Like we integrate module A to B, and then from B to C, B and C to integrate with C. So incrementally we are adding the modules using the stubs and drivers. So we'll discuss about what even by stubs and driver to uncover the defects. This approach is known as incremental integration testing. Now what do you mean by stubs and drivers? So what happens is, let's say we have module A. Now we are integrating with the sub module. This is sub module, this is main module, guys. So this is main module or parent module, and this is child module or sub module. Now we are integrating with these two, correct? So let's say this is under process, this is not yet done, but still we wants to do integration testing. So we create a program called stubs, temporary program. So that is nothing but the stubs. So we'll discuss in coming slides. Testing, in which components or systems are integrated and tested as long as all components or system are integrated and tested completely. So this is about incremental approach. So what are the three types? We have top down integration, bottom up integration, and mixed. So what do you mean by top down? testing is conduct from main module to sub module. In this approach, verify the data updated in main module and is updated in sub module. So let's say take an example of login page and home page. Correct. Now we'll verify, because we'll verify here. We'll integrate first login with home page. Now testing is conduct from main module to sub module. So this is my main module, login page is my main module, and this is sub module. So how the data is flow, because until unless we don't log in with username and password, it won't log in with it won't land on this home page. So in this approach, verify the data is updated in main module is updated in the sub module. So here it will showcase the username, right? So it depends on this module. So data will be updated once we log in in the application. Bottom up integration. So testing is conduct from sub module and verify the data tested in sub module, thus make sure the highest module is tested properly. So let's say in case if this module is developed and this module is not developed, so we'll use the driver over here. So they will create a driver. Now we have this home page. So to run this program, we need to supply the username and password. So what they will do, they will create one valid user or some function. So that will call that will supply the username and password and will land on this particular page, home page. And later on they will develop the module login page module. Anyway, we'll discuss about top down, bottom up integration in coming slides. What about mixed or sandwich integration? So it is a combination of top down and bottom up integration. So this is the combination of both the bottom up, top down and bottom up integration. So what do you mean by stubs and driver, guys? So these are the temporary components which are used in place of sub module and main module. Stubs. What do you mean by stubs? So it is substitute of sub module in top down integration approach, and driver, it is substitute of main module in bottom up integration approach. So I'll show you with the help of diagram in the next slide. So here you can see this is stubs. So here our main module is done. Okay, this is top down approach, guys. So here you can see top down approach, and here our sub module is under maintenance, under development. What developer done here is they have created a stub. So some functionality they have created a temporary program for testing purpose, for test. So this is how we perform top down. So basically what happens in top down integration is, without developing the next module, sub module, we can still perform using these stubs. So this will act as a sub module. Now just reverse bottom up. So here we in case we have taken an example of home page, right? So this is take an example. This is our home page. So home page is already done over here, but our main module which is login screen is not yet done. This is under development, main module. So here driver will act as main module, which will provide the user ID and password for this home page. So what they will do, they will create one temporary program which will supply the user ID and password for this home page screen. So this is for test, right? This is driver, right? So this is bottom up approach, guys. So what are the advantages of integration testing? So it ensures that internal modules and components communicate properly, and it performs regression testing on important connection points. So it performs regression testing also on important interfaces between two modules. It also helps to detect the issues related to the interface between the modules. Integration testing helps to simulate the interaction between various modules. So basically integration testing talks about the interaction between the two modules. It covers multiple modules to provide broader test coverage. So this is the biggest advantage of integration testing, provide the broader test coverage if it covers the interfaces between two modules, like how they are connected with each other. So what are the disadvantages or limitations of integration testing? So difficult to perform because it is time taking process, as well as it's very difficult because how the modules are integrated with each other. So that we need to understand in integration testing. So it's very difficult to perform as compared to system testing, in which we can consider the application as a black box. So in if we talk about black box, so we can directly consider like a black box when we talk about system testing, where we need to just talk about like how the functionality are working in the integrated system. We don't care about how it is working internally. So that is the biggest one of the disadvantages of integration testing. Time consuming. It is very time consuming and resource intensive to test all the interfacing between the different connected modules. It's time taking process, guys. And additional efforts, it requires the creation of stubs and drivers. So this is what we have spoken about. Top down and bottom up approaches of incremental approach, which if not created correctly can result in inadequate testing. So the developer should create proper stubs and drivers so that integration testing will be smoothly done. So this is all about integration testing, guys. So if you have any questions, then please write your question in the comment box, and please like this video, share it. And if you are new to my channel, then please subscribe it and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what is system testing and what are the different types of system testing. So let's get started. So what is system testing? So guys, already we have spoken about what do you mean by unit testing and what is integration testing. So if you haven't watched those videos, then I would recommend first go through those videos and please watch them and come back to this video. So I have provided the link in the description box of this video, the complete manual testing playlist. So please go there and watch them, and then please come back to this video. Now if you talk about like briefly, if you talk about unit testing, so what we have done in as part of unit testing, we have tested the individual module. So that is nothing but the unit testing. So these are the, we are developing a software, guys, and these are the part of, so we have tested individual module in as part of unit level testing. So this is my first level, which is performed by developer or white box tester. So we have tested all the modules individually. Later on we'll integrate all the modules together, and when we perform the testing on integrated module, so this level is called integration testing. Integration test level or integration testing. So what we do here, so we mainly check the data flow from one module to another module. So here we have different modules which are integrated, and we mainly check the data flow from one module to another module. So that is the main purpose of integration testing. We check the interfaces between the modules. That is integration level or integration testing. Now the third level is system test, and we perform on integrated system. So this is my third level, guys. So this is called system testing level, system test level or system testing. So this is performed once all the modules are integrated and tested as part of integration testing. Then we go for system testing. So what we test over here, so basically we check the functional aspect and non-functional aspects of the software or our system. So that is part of system testing, that is system testing. Here we also check like end-to-end testing. So what is the meaning of end-to-end testing, and what is the difference between end-to-end testing and system testing? So in end-to-end testing, what we do, we check the data flow from beginning to the end. We check the functionality from one point to another point, like from beginning till the end. We'll check the complete flow of the application. So this may be in one system or maybe different system as well. how the data is flow from one system to another system. Whereas in system testing will test in one integrated system, so that is called the system testing. And we can say, guys, system testing is the superset of end-to-end testing. So we can say end-to-end testing is the part of system testing, or in other words we can say uh, end-to-end testing is the subset of system testing. System testing is the superset of end-to-end testing, and end-to-end testing is the subset of system testing. And in any other differences between system test and uh, end-to-end testing is we perform system testing after the integration testing. Here you can see after the integration testing we perform system testing, and end-to-end testing is performed as part of system testing only. So these are the differences between system testing and end-to-end testing. And the fourth level will be UAT, which will be done by the end user. And you can see, guys, this is completely done by the tester system test, and this is done by the developer or white box tester, and this is done by the tester, and in some companies with the help of developer as well. And this is the system, this is the testing where completely testers are involved. And because here there is no involvement of the developer or the end user, and this is completely by the end user. So this is all about system testing, guys, which we are going to discuss today. So now let's talk about some of the theoretical stuff about the system testing. So system testing is testing conducted or on a complete integrated system to evaluate the system's compliance with its specified requirements. So whatever requirements we have we got from the customer, we have created the system test plan we have already spoken about as part of verification and validation model. So as part of whatever requirements we have captured, we test the system test, like all the functionality is working perfectly fine and perfectly fine or not. And we do check the functional as well as non-functional aspect of the system. Testing is conducted by the tester, which we have spoken about, and it is black box testing. So what do you mean by black box testing? So mainly we focus on the application, functionality of the application. We don't focus on the like the other like non-functional function of the application, like security, performance, or internal structure of the system. Mainly we'll focus on the, we don't care about the internal structure of the system, we mainly focus on the functionality of the application. So that is black box testing. So this testing is conducted after the complete code is developed, and during system testing we will conduct both functional and non-functional testing, which we have spoken about. So what are the different types of system testing, guys? So I already have discussed, like we have functional testing and non-functional testing. Yeah, so these are the different testing, guys, we perform as part of functional testing as well as part of non-functional testing. So these are the different testing we perform. And if you remember, I have already created a video on testing hierarchy where I have explained like in brief about all these testing which I have mentioned over here, like whatever functional testing, user interface testing, object properties, error guessing, input domain, already I have explained. So I'll provide the link in the description box of this video on top of it, so you can go there and watch this the complete testing hierarchy. So you will understand better. So this diagram is the part of that testing hierarchy, guys. And also I have spoken about non-functional testing as well in brief. However, in coming days I'll explain each of the testing in a separate video, and I'll explain with the help of an example as well. So let's move on. So what are the advantages of system testing? So it helps in getting maximum bugs before acceptance testing, because we do perform functional as well as non-functional testing, so we get so many defects in terms of functionality and non-function of the application. It ensures the application is validated as per customer requirement, software requirement specification, and functional requirement specification, because we do write the system test cases as part of based on software requirement specification and functional requirement specification. So what is SRS? So this talks about the functionality of the application, or and functional requirement specification is also, but this is detail level, guys. So functional requirement specification will talk about the functionality in detail level. So mainly this is used by the tester only testing team, but will also take an example of take help of SRS as well, which is mainly used by the project manager or subject matter experts or business analyst. So it is first testing level in which whole system is under test from end to end. So we have already spoken about end to end testing as well. So this is the phase where the whole system is under test from end to end. This technique phase uses the test environment which is similar to the real business environment or production environment. So yeah, this is same like the production environment, guys. So once all the systems are integrated, once everything is done, development and everything is done, then we go for the system testing. So it will be like staging requirement, or it will be a kind of replica of the production environment. So you can treat like this. So what is functional testing, guys? So these are black box testing techniques. So I have already spoken about, which test the functionality of the application. Functional testing validate the application's functionality is working as per requirement or not. So in functional testing, we do care about how the system is uh, performing functionally, like how it is functioning, whether it is functioning correctly or not as part of functional testing. So take an example of Gmail. So whatever we do in Gmail, like we log in into the Gmail and we compose the email and we send the email, we write to address to where we are going to send the email and subject line, and we'll write in the body our contents and then send the email. And once we send the email, it will go to the send box, correct? And sent items it will go. So this is what we test as part of functional testing. Like the functionality we will check, we don't care about how internally it works and what is the performance to send the email, how much time it is taking, what is the security things, security related things, we don't care about that. So this is functional testing. It is quality assurance process. Functions are tested by feeding them input and examining the output. So feeding them input means we are sending the email, we are putting the data, we are putting some data over there, like to address, and then we are putting the subject line, and we are putting body also, the contents as well. After sending the email, we will go to the recipient and will verify whatever we have sent, whether we have received those or not. So that is kind like we are providing the data input and we are getting the in terms of output. So based on the data, like whatever we have provided, we verify whether we are getting the expected outcome or not. So these are the different we have seen in the diagram also, guys, type of functional testing: user interface testing, object properties testing, we have error guessing testing, input domain, database testing, calculation testing, links and URL testing. These are the different testing. And as I have already told, so as part of hierarchy, when I have explained the hierarchy, complete hierarchy of the software testing, where I have spoken about the brief about all this testing. So please go and watch that video. The link is given in the description box. Non-functional testing. So what do you mean by non-functional testing? So it is the type of testing where we check non-functional aspects like performance, usability, reliability, etc. of a software application. We test the characteristics and feature of an application. Non-functional testing has a goal to validate the performance of the software. So what are the different types of non-functional testing, guys? So we have usability testing, performance testing, memory leakage testing, volume testing, compatibility testing, security testing, configuration testing, and recovery testing. and we have installation testing as well. So if you want to, again, I have provided the link in the description box, so please go that complete testing hierarchy where you can understand better. And however, in coming days I'll talk about all these testing types in detail with the help of example as well. The last one is compliance testing. So this is all for today, guys, about the system testing. So thank you for watching. Have a nice day. Bye bye. So guys, if you are new to my channel, then please subscribe it and click the bell icon to get the notification for upcoming videos. Thank you. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about acceptance testing and its levels, like alpha and beta level testing. So acceptance testing is the highest level in software development lifecycle, guys. Highest level of testing. So we have different levels of testing, like unit level testing, integration level testing, system level testing, and this is the highest level, which is acceptance testing. So if you haven't watched those videos like unit testing, integration testing, and system level testing, then please go and watch those videos. I have provided the link in the description box of this video, guys, and then come back to this video. So this is the highest level of testing, and this is also called UAT, user acceptance testing, guys. So let's talk about more about acceptance testing in detail. So before I move towards the theoretical stuff, like what do you mean by UAT and what is alpha testing, what is beta testing, and what are their advantages, let me just explain you like what is acceptance testing or UAT testing, and why do we need UAT testing, and how do we perform this UAT testing. So let's get started. So take an example, guys. We are working for this company. So this is our software development company. We are working for a software development company, and this is the customer which we are dealing with. Now this customer wants to have a software. They want to build a software from our company. So they requested our company to build a software for their clients. So what they will do, they have given their requirements in the form of customer requirement specification. Now what our company will do, our BAs, business analysts, work with their requirements, work with client or customer, and get the requirement in the form of CRS, and BA will convert them into different documents for our company's understanding. Like we have software requirement specification, we have functional requirement specification, or we have business requirement document. This is just for our understanding. BA will convert them into different documents, which we have already spoken about at the time of software development lifecycle. Now what our company will do, now we got the requirement and we'll develop a software. We'll develop a software or application for customer, and once we have to follow the software development lifecycle, correct? We have followed the software development lifecycle to build this software. Like we have requirement analysis, we have feasibility study, we have design, coding. Now when we talk about testing, we have performed different testing. We have done unit testing, we have integration testing, we have system testing. Now we need to perform the highest level of testing, which is acceptance testing. So how do we do this acceptance testing, and why do we need acceptance testing? So what happens is, whenever we build a software, customer wants to have a final look of the software, like how the functionality is, how the workflow is, how the interface is, and how the feature, what are the features they have included as per our requirement or not. So this is what the customer wants to do the UAT. So this is one of the reasons because they are paying for this software, right? They are paying to our company to have the software, to get the software. So they want to have a final look of the software, they want to review it. So that is the reason they want to do the UAT testing, that is user acceptance. So based on that, they will accept the software, they will accept the application. Now user acceptance, another reason could be, so whatever documents we have written over here, we have gathered the requirement from the customer, that might be misunderstood by our developer while developing the software by our development team and testing team while developing the software and testing the software. So that could be another reason customer wants to review the software, whether they have captured all the requirement or not, they have implemented all those requirements as per our expectations or not, whether the design is whatever they have designed in the application that fulfill our expectations or not. That is the reason customer wants to do the UAT testing. So in most of the companies, guys, we have pre-UAT and post-UAT, and in some companies we do only UAT testing. So pre-UAT, so here we have pre-UAT, and this is also called alpha testing, alpha. And at customer end we do beta testing, and this is called post-UAT, post-UAT. So now we'll do the pre-UAT testing. We'll create a test plan, pre-UAT test plan, scenarios and test cases, and with our testers and BAs involved in this pre-UAT test, and we'll do the pre-UAT test at our end, alpha or alpha testing at developers end. So this is development company, guys. So our in testing environment will do the pre-UAT testing. Now if everything goes well, then we pass the pre-UAT test. Otherwise, if we get any defect, then we'll get it fixed by the development team, and we'll release the software to the customer for beta testing or post UAT testing. Now they will perform at their end. This is real time environment, guys. Real time environment or staging environment, just like production. So this is production environment, so it will be just like production environment. So they will execute some real time scenarios. They have their own testing team there, including BAs. So they will perform the post UAT testing. So they have set of UAT test cases, and they will execute those test cases. Now if they are not happy with some of the requirements which we have developed, so they will revert it back, or if they get any UAT defects, so they will revert it back to our development team. Now we'll redevelop those functionalities or requirements from the customer, or suppose they have missed some requirements from while giving the CRS at the time of initial requirement given, giving the while giving the at the time of initial requirement, if they missed some requirement, so they will add while doing the UAT, and they will revert it to the development team. Now we'll redevelop all those requirements and will revert it back to the customer again. Now again they will execute their post UAT test cases or beta level testing they will perform. Now if everything goes well, they will release the software into production with, and they will release the software to their customer, their own clients. So this is how it is happening, guys, the acceptance testing or UAT testing. So as I have told, like some companies, they are following pre-UAT and post-UAT, which is called alpha testing and beta testing. And in some companies we used to do only UAT at customer end. So this is all about acceptance testing, guys. Now let's talk about like theoretical stuff and what is alpha testing exactly, and what are the different advantages of alpha and beta testing. So let's move on to the next slide. So after testing is completed by tester before deploying the application into production, business user will conduct testing to ensure the application is working as per their requirement or not, called acceptance testing, which we have discussed. This is a type of testing done by users, customers, or other authorized entities to determine application software needs and business process. So this is done at our end, which is developers end, which is called alpha testing. Another way to do UAT is if they release their software to their own customers. So we can do the UAT at their end as well. They will perform the UAT at their end as well. So that is another way to do the UAT testing. Software testing, where a system is tested for acceptability. So whether to accept that software or not. So that is evaluate using this UAT testing. What are the different levels of acceptance testing, guys? So we have discussed, we have two levels: alpha test or pre-UAT, beta test, or post-UAT. So here you can see alpha testing and beta testing. Advantages of acceptance testing. So reduces the risk of defects being identified in production. It increases the satisfaction of clients as they test application itself, increasing software robustness and usability, and increase end user happiness. So these are the different advantages of doing acceptance testing, guys. Now let's talk about alpha test. Alpha testing is conducted in the development company, which we have already spoken about. Alpha tests are carried out early in the development process by internal staff. Project manager teams up with the developer to define a specific goal for alpha testing. Testing is conducted in test environment. So this is what we have spoken about. Testing is done by testers and quality analyst. So quality analyst is nothing but the business analyst, and some QA group is also there, and testers with the help of them will do the UAT testing. We have will create certain test plan and scenarios and test cases as well to perform pre-UAT testing. Testing is conducted for application and product. So what are the advantages of alpha testing or pre-UAT, guys? So it helps to uncover bugs that can pose a serious threat. It helps to deliver good quality software or beta testing. So during this testing, the real world behavior of the users and the environment is imitated. Correct. So we'll try to imitate the real world scenarios. So what is beta test? Testing is conducted at customer location. Beta testing is one of the final steps in your software development lifecycle before a product goes live. Beta testing is performed by the real users of the software application in real environment. So this is what we have discussed so far. At the beginning we have discussed beta testing allows a company to test post launch infrastructure. Advantages of beta testing or post UAT. Direct feedback from customer is major advantage of beta testing. So we'll get the direct feedback from the customer, like what exactly they want to have change in the software. Reduces product failure risk via customer validation. Improves product quality via customer feedback. So yeah, this is all about acceptance testing, guys. So if you have any questions, please write in the comment box of this video, and please like it, share it, and if you are new to my channel, then please subscribe it and click the bell icon to get the upcoming interesting videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about the difference between system testing and integration testing. So basically we do perform system testing and integration testing on integrated system, but we need to understand like what is the exact difference between system testing and integration testing. So let's get started. So what is system testing? So when we check the behavior of all the modules, behavior of all the modules as a whole. Correct. When we check all the modules as a whole system, then we perform system testing. So that is the when we check the behavior of all the modules as a single unit. Correct. So that is nothing but the system testing. And what we check in integration testing, interfaces between the modules, interfaces between the modules. That is system testing. What is the second point? What is the second difference? Okay, so here what kind of technique we use? Before that, what are the testing we perform? Here we perform functional and non-functional, functional and non-functional, and here we perform functional only. So what is the difference between functional and non-functional? Here in functional we do the UI testing and input domain testing and database testing. So these are comes under functional testing, whereas in non-functional testing we do check performance, security, memory leakage. So these are all comes under non-functional testing. So what is the third difference, guys? We perform system testing after integration. After integration testing, and we do perform integration after unit testing. So we have already spoken about unit testing, integration testing, system testing, and acceptance testing. So this is the level, guys. These is the different levels in software testing: unit testing, integration testing, system testing, and acceptance testing. Now fourth point is which technique we use. So we use black box technique, and here we use black box plus white box. So black box means we don't care about the internal structure of the system. We check mainly the functionality. What is the fifth point? Fifth difference. So here we create the real-time scenarios. Here we'll test with try to create the real-time scenarios, or you can say created to imitate real time or real life scenarios. And here we try to simulate interactions between modules. What is sixth point, guys? Sixth difference. This is performed. System testing is performed by testers, and here integration testing is performed by testers as well as developer in some companies, because we need to check the interfaces between modules. So that's why some typical scenarios we need developer involvement as well. So these are the different points which we talked about, the difference between system testing and integration testing. So guys, if you still have some doubts, then please let me know. Write your question on the comment box of this video. Thank you so much for watching this video. Have a nice day. Bye bye.